Hello, everybody. So we're today talking about factoring. We're going to spend a few days on this. This is a very, very important topic, factoring. And factoring is going to be in pretty much every math class you take for the rest of your career. However many math classes that is, I don't know. But a factoring is the act of separating something into factors. So separating something into one one thing times another thing. Sometimes you've got many factors. A lot of the times you just have two or three. So if I were to start off with 2x plus 7 times x minus 10 and multiply, which means I would have to distribute, that act is called simplifying or just specifically multiplying. So you would end up with this trinomial. But if I were to give you this trinomial and ask you to rewrite it as something times something else, that is called factoring. And there's lots of ways to get from the bottom one to the top one. And I don't care how you do it because there are many, many legitimate ways. If you just want to go to YouTube and search, how do I factor a trinomial and find something you like, go for it. And I know you've heard this, how to do this lots of times. So I'm going to give you a new way to think about it. When I learned it, I learned about guessing and checking. So, and that's usually, well, let's just go through it. So I'm multiplying two binomials. And A, B, C, and D are just any, they could be any number, positive or negative or zero. They could be anything. So AX plus B times CX plus D. And if I were to multiply this, I would have to take AX times CX, which is AC x squared. So A times C x squared. I would have to do AX times D, which is ADX. I would have to do B times CX, which is BCX, and I would have to do B times D. So I would get four terms. The middle two terms would be like terms, so I can add them up. If this were like 7x and 5x, they would add up to 12x because I would add the two coefficients, 7 and 5. Well, I don't know what those two things are, but I do know that I'd have to add them up, AD plus BC, whatever that is, and then put an x on it. Well, when I finally add those two like terms, I would have three terms. So a trinomial. And let's look at this trinomial, for example. This trinomial is the result of, if it's factorable, I want it to get all the way back to this factor times this factor. So the first term is a times c x squared. So this number times this number, the a times the c. Well, this is 1x squared. So there's only one way to get to take two numbers and multiply it by one. Well, two integers. You could take 1 times 1 or negative 1 times negative 1, but most often it's just 1 times 1. So right away, when I try to factor this trinomial, it's going to be 1x with something times 1x with something. And then I notice that this 2 is b times d. So b is this term, this number right here, and d is this number right here. So when I multiply these two numbers, I should get 2. Well, what two numbers multiply to 2? 2 is prime, so it's just 2 and 1. And so this is the factorization of this trinomial. If I were to multiply this out, I would get this. Let's practice that again. So 3x squared plus 8x plus 5. How can I factor this? I know that the first two, to get to 3x squared, the a times the c has to equal 3. Well, 3 is prime. So there's only one way to get to 3, and that's if one factor is 3x and the other one starts with 1x. It has to start this way. And it truly does have to start this way. There's no other. We're talking about factoring with integers, so all these should be just integers. And then the two numbers over here have to multiply to 5. The b and the d are going to go here and here, and they have to multiply to 5. So I got two scenarios. I could put the 5 first and then the 1, or have the 3x tied with the 1, or x plus 5 and 3x plus 1. These are two different results. So how am I going to get this 8? Well, here I just need to do a little bit of mental math. If I put a 5 right here and a 1 over here, then I would have, first of all, I need a 1 times a 5 to get this 5 right here. Well, when I multiply this out, when I FOIL, 3x times 5 would be 15, and 1 times x is 1x. So 15x plus 1x is 16x, and I need 8x for my middle term. So I can reverse these. If I put the 5 here and the 1 here, now if I multiply this out, 3x times 1 is 3x, 5 times x is 5x, and 3x plus 5x does add up to 8. So this is the correct factorization, this guy right there. My computer is just frozen. Come on. This one is a bit more challenging. So this trinomial, these two numbers have to, A and C, have to multiply to 7x. Well, again, lucky that 7 is prime. So it has to be 7x plus or minus something times 1x plus or minus something. It truly has to be. But then these two numbers over here have to multiply to negative 8. And there are a lot of options. There are 8 options. Notice all 8 of these options. The first term of each binomial, they both multiply to 7x squared. And then the second term on each trinomial, they both multiply to negative 8. But there are 8 different ways to do this. I could put a positive 8 and a negative 1, or a negative 8 and a positive 1. Positive 1, negative 8, and so on. And then you got the 4 and the negative 2 and all that. So one of these will multiply to our correct answer. Only one of these. 7x squared, all 8 multiply to 7x squared. All 8 will multiply to negative 8, but only one of these will get me 26x. And which one is it? Well, just a little bit of a mental math. You multiply the outer and the inner terms. So 7x times negative 1 is negative 7. 8 times x is 8. So what's negative 7 plus 8? That's positive 1. I need 26. And the more you practice this, knowing that this is 26 and you've got a 7 here, well, 7 times 4 is 28. And so that's this option down here. 7 and 4 is 28, which is close to 26. But then also there's this inner term, negative 2 and x. Negative 2 and 28 make 26. So this is the key. That's our answer. When I multiply these two binomials, I will get 7x squared plus 26x minus 8. The other 7 will multiply to something else. The middle term will be different for each of these 7 other options. One more. So here, a times c has to be 6. Well, there are a couple of ways to get 6. It could be 3 times 2, or it could be 2 times 3, or it could be 6 times 1, or 1 times 6. So I've got some options to get to 6, but 5 is prime. So I know, I'm not sure what the first part is going to be, but I know the second part is going to be 5 and 1, because 5 is prime. But I notice that there's this negative 17 here. So to get this negative, is there another way to multiply to positive 5 and to introduce negatives? And the answer is yes. Realize negative 5 and negative 1 also multiply to positive 5. So I'm thinking when I factor this, it's going to factor into something like this. Something minus 5 times something minus 1. Again, negative 5 times negative 1 gives me my positive 5. These two numbers have to multiply to 6. And there aren't too many options for us. There's only these 4. Notice the second term on both binomials multiply to positive 5. The first term of each set multiplies to positive 6x squared. So which one of these is going to give me negative 17? Well, doing a quick look here, I see this 5 and a 3. Negative 5 and 3 make negative 15. And then the outer 2 and negative 1 make negative 2. So negative 15 and negative 2 add up to negative 17. So that is the correct solution. That one, 6x squared minus 17x plus 5 factors into that. So the other three are not solutions. Last slide. There is something called a master product algorithm, and that algorithm will work for every single factorable trinomial. And you've seen it before. It's similar to the box method. I would bet $100 that you've seen it before. There is a YouTube video that I put on the modules for you to watch, but being a senior in high school, you probably have your own way to factor these things. But we'll go through this very quickly. So we already know the answer to this one. This is from our previous page. We know it's 7x minus 2 times x plus 4. But to do this by the master product algorithm, you take the outer two numbers and you multiply them. 7 times negative 8 gives me negative 56. Then you have to find two numbers that multiply to negative 56 and add to the middle term, which is 26. And this is the hardest part. So if you can do this part, then you've gone over the hardest part. The two numbers in this case are 28 and negative 2. 28 times negative 2 equals negative 56. And if you add these two, you get positive 26. So it all works out. Now, what do you do with those numbers? You split up this middle term. So I'm going to rewrite this trinomial, but instead of 26, I'm going to write it as 28 and then minus 2. So 28x minus 2x. Notice that these two are like terms, and I know that if I just subtract these two, I'll get right back to my original. So I know I'm not wrong here. And then you factor by grouping. These two terms both have a 7x in common. So you factor out a 7x from both of these. You're left with an x from this term and a 4 from that term. These two terms have a negative 2 in common. So you factor out a negative 2. And taking out a negative 2 from here leaves you with x. And taking out a negative 2 from here leaves you with positive 4. Now, these two big terms both have an x plus 4 in common. So you factor that out, and you're left with 7x minus 2, which was the same answer over here in a different order. But order doesn't matter because multiplication is commutative. I could just put this x plus 4 in front, and it wouldn't change the final answer. This still says x plus 4. Lastly, our first slide. Remember our first slide was just this top 3 lines right here? Well, if I were to factor this using the master product, you would multiply 2 times negative 70, which is negative 140, and then find two numbers that multiply to negative 140, but also add to negative 13. Those two numbers are negative 20 and 7. And then you factor by grouping. These two both have a 2x in common. You take that out. These two both have a 7 in common. You take that out. And you're left with two binomials that are the same, x minus 10 and x minus 10. You take that out and you've factored completely.